Now let's see the variation of Gibbs free energy change with temperature. Gibbs free energy G is equal to H minus Ts. From this, what is dg? dg is equal to dH minus TdS minus SdT. Okay, what is H? H is U plus PV, or dH is equal to du plus PdV plus VdP. Okay, what is du plus PdV? That is TdS from the combination of first and second law. Therefore, dH is equal to du TdS plus VdP. Substituting the value of dH, we get dg is equal to TdS plus VdP minus TdS minus SdT. TdS and TdS cancel out, and what is left is dg is equal to VdP minus SdT. So from this we have to find the variation of free energy with temperature and pressure. Dou G by dou T gives the variation of free energy with temperature. Dou G by dou T at constant pressure will give you, pressure constant means dP is 0. What is left is minus S. Similarly, dou G by dou P at constant temperature. That means dt is 0. What is left is V. This gives the variation of free energy with temperature and pressure. Okay. We have dou G by dou P at constant temperature as equal to P. Or from this, what is dg? Sorry, as V. It's not P, that's V. Sorry. dg is equal to V into dP. How do we get that? We are cross multiplying, and hence we get dg is equal to VdP at constant temperature. But for an ideal gas, PV is equal to nRT, and for 1 mole PV is equal to RT. From this, what is V? RT by P, or dg is equal to RT by P into dP. Okay, substituting for V. Integrating between limits 1 and 2, G1 to G2 dg is equal to R is constant, T is kept constant. We get R into T integral dP by P between limits P1 to P2. What is integral dg? dg is G. G between limits G1 and G2 implies this is G2 minus G1 is equal to RT into, what is integral dP by P? That is ln P between limits P1 and P2. This is delta G is equal to RT ln P between limits P2 and P1 is ln P2 minus ln P1, and that equates to ln P2 by P1. Okay. This is the equation for calculating delta G if we are given the pressure at two different conditions. Okay, delta G is equal to RT ln P2 by P1. You have to remember this equation. You will get problems, and in order to solve the problems you need this equation. Okay, similarly Similarly, we have dou A by dou V at constant temperature is equal to minus P. Dou A by dou V at constant temperature is equal to minus P. From this, what is dA? dA is minus PdV at constant temperature. Doing the same procedure as before, integrating between limits a1 and a2, dA is equal to, for P we can substitute as integral P1 to P2 minus RT by V dV. What is integral dA between limits a1 and a2? Delta A. Minus constant, R constant, T is constant. Integral dV by V is ln V. This is V1 and V2. ln V between limits V1 and V2 implies RT ln V2 by V1. This gives the expression for delta A in terms of two different volumes. A process involving change in volume from V2 to V1, delta A is minus RT ln V2 by V1. Similarly, we have delta G is equal to RT ln P2 by P1. Okay. This is for 1 mole. For n moles, the equation becomes delta G is equal to minus nRT ln V2 by V1 and delta G is equal to nRT ln P2 by P1. Okay. This gives the variation of Gibbs free energy change and Helmholtz free energy change with pressure and with volume at constant temperature. You have to remember this equation. It will be useful for you to solve problems. Now we'll move on to the criteria for spontaneity and equilibrium.